fellas. Happy Ties Day. This is Super B shouting out to my genius physics students here. This is a 27-degree incline here. There's an object on it right there. I want to show the forces acting on this block right here. So the first force I want to draw in purple is the perpendicular force, which of course is perpendicular to the incline, like so. Got it? Mm-hmm. Now, the other force that's acting on it is so that's the normal force, perpendicular to the incline. The other force, which, hold on, let me draw it in a different color. Let's make it brown. No, let's make it pink. Yeah. Okay, it's going to be pink. And it's going to go parallel to the incline. Parallel. Which will be the force applied. Or the force of friction. All right, if it's moving at a constant velocity. If it's moving at a constant velocity. Okay? Now, this perpendicular force and this parallel force are components of a right triangle. So, just to show, this is 27 degrees. This is also 27 degrees, which I'm going to actually measure for you, which will be right there. So, this force right here is the weight, which pulls straight down. Force, weight, or force gravitational. So there we go. So now we have force normal, perpendicular to the incline, force parallel, force applied, force of friction, which is this one, and then weight is pulling straight down, force gravity or force weight. All right, and this angle right here is 27 degrees, as you saw that I measured it, just like the incline is 27 degrees. All right, so if I put this block on the incline and it starts to move, we can figure out coefficient of static friction, which is going to be equal to force of friction, which is equal to the force applied, since it's moving at a constant velocity, over the normal force, which in this case is not the weight because it's reduced. The gravitational force is reduced because of the incline, and the bigger it gets, the bigger the normal force gets. Okay, or the smaller the normal force gets. So, here we go. Now, if I want to find the force applied, I can look at this triangle right here and see that it's opposite over hypotenuse, which is sine theta times FG. Boom. And if I want to find the perpendicular force, which is adjacent, I say cosine theta times FG. Now let me show you a nice little trick here, geniuses out there. This is sine theta over cosine theta. Those cross out. Sine theta over cosine theta, for those of you who know your trig identities, is tan theta. Blu-ray. So tan theta is going to be the coefficient of friction, and if you figure out the tan at 27 degrees, guess what you're going to get? 0.50. Guess what? That is the coefficient of static friction for wood on wood, which is what we did in the class today. Boom, boom. Enjoy yourself. Thank you very much. Signing off. Stop it.